in this session, we will start by seeing equation of motions in general plane motion. So we have already covered equations of motion in case of translation and equation of motion in case of pure rotation about a fixed axis. Now we will consider equations for general plane motion. When we say general plane motion, we mean that the motion is a combination of translation and rotation. Okay? In this case, we have at each instant a new instantaneous center of rotation. In this case, the three equations used are sum of x equals magx, sum of y equals magy, and sum of moments about g equals to ig alpha. Okay? So because we don't have a certain point that is fixed, we cannot say that sum of moments about O equals to inertia about O times alpha, because we don't have any point fixed on the rigid body. Okay? And please pay attention, you cannot say that sum of moments about the instantaneous center is equal to inertia about IC times alpha. It's not applicable. It's only applicable in one particular case where you have a disk rolling without slipping, as it should be a homogeneous disk. So to not have any conflict, okay, don't use only sum of moment in general plane motion. Use only sum of moments about g equals to ig alpha. Okay. And if you choose to any other point on your body and you want to do sum of moments about p, then you should do ig alpha plus moment of vector mag about p, which is the general case we have covered last time. Okay? So if you choose any point different than g, then when you do sum of moments about p, you will do ig alpha plus moment of vector mag about the point. Okay? Now, let's do a problem on this. Determine the angular acceleration of the spool. The spool has a mass of 8 kg and a radius of gyration of 0.35. The cords of negligible mass are wrapped around its inner hub and outer rim. So in this problem, we have the following rigid body connected to a cable. Okay? This cable is going through the outer and inner hub of the spool. Okay, so first what we want to find here is they asked about the angular acceleration of the spool. So my first unknown here is alpha. So I don't know alpha first. What are my other unknowns? What are my other unknowns?
Tension.
No, tension is 100 Newton. Okay, it's given. Okay, the force here is given equal to 100 Newton. Okay.
بالكيبل الثاني لا.
بس بالكورد الثاني لا، يعني هون عندنا بس here you have it's the same cable, but because we don't know if we have slipping or not, okay, then we can put the tension here at A, TA. So we have TA, okay, but when they don't mention anything, then we can say that we have rolling without slipping. We have rolling without slipping, so at A, what is the velocity at A?
The same as G, man.
No. If we have rolling without slipping, this means what? Yes, very good, Mustafa. It's zero. Why it's zero? Because having rolling without slipping means that at this point the velocity is the same for the disk and for the cable. And because the cable is attached to the fixed level, okay, then we can say that the velocity at point A is 0, okay? So we have rolling without slipping, and the instantaneous center is point A. So here, we have alpha is unknown. We have the tension here, tension T, in the cable. We have the weight of the pulley and the acceleration. If you want to put all forces, we have the weight of the pulley here. This is W, okay? And we know that the acceleration of G will be in which direction? In which direction is acceleration of G? It's upward along Y direction, okay? Why it's upward? Because if you have rolling without slipping, in case of rolling without slipping, then the velocity of the center, okay, is equal to R omega. And it will be along a straight line because the distance between A and G is always constant. The distance here from A to G is always constant, okay? So G will move on a line that is parallel to the cable, and because I have 100 Newton force is upward, then I will have rotation of the disk in the clockwise direction, and acceleration of G will be upward. Okay, so this is the other unknown here is AG. So until now, my unknowns are AG, T, and alpha. So I have these three unknowns, okay? I will start to write my equations. If I want to get, if I don't want to find the tension, I want to find just two equations to give me AG. What can I do? Can you solve this problem without calculating tension T? What should I do to avoid calculating tension T?
If we take moments about A,
Very good. If we take moments about A, what will be the equation? If I do sum of moments about A.
and we can use the parallel axis theorem.
Yes, if I do sum of moments about A, okay, sum of moments about A is equal to IG alpha, IG times alpha, okay, plus what?
Plus المومنت MAG.
Very good. From the formula we have developed last time, it's plus moment of vector MAG about which point?
Point A.
About A. Okay, so in this case, what are the forces doing moment about A? I have, if I choose the clockwise direction as positive, I have plus 100 times this distance. What is the distance here? It's equal to the inner radius. The inner radius is 0.2. Okay, so 100 times 0.2, and for the weight, it's in the counterclockwise direction, so it's minus. We are doing moment about A, so the distance would be what? 0.2 plus
0.7 plus 0.2
yes.
plus 0.4.
So it's 0.7. Okay, so here we should add 0.2 plus 0.7. Okay, so it's 100 times 0.5. خلينا نمحى يلا. So the summation of moment is 100 times 0.7 And we have the moment of the weight, which is in the opposite direction. So minus W times which distance to A?
0.5.
0.5 equals to IG alpha plus what? What is moment of vector MAG about A?
AG times 0.5.
This is vector MAG, okay? Vector MAG is upward. It's producing a clockwise moment about A. So it's plus MAG times distance 0.5.
0.5.
Okay. So plus MAG times 0.5. في شغله منير قلت لي انه فينا نعمل parallel axis theorem. بليز انتبهوا هون ما فيني اعمل IA alpha. I cannot write that sum of moments about A equals to IA alpha الا اذا هن قالوا لي انه I have a homogeneous disk. اوكي بما انه ما قالوا لي انه I have a homogeneous disk وانا قلت لكم انه بالgeneral motion you can only apply sum of moment equal inertia about instantaneous center times alpha only if it is a homogeneous disk. So to be on the safe side, always do sum of moment about the general relation. Sum of moment about A equals IG alpha plus moment of vector MAG about A. Okay? So here, in this relation, we have two unknowns. We have alpha and AG. So we need another relation between alpha and AG. What is the relation between alpha and AG?
Alpha is AG times R.
Which are?
That's 0.5.
Gyration.
Very good. لا الجايريشن بشو بعوزها الجايريشن؟ بعوزها بدي اجيب الاي جي. الاي جي is equal to m times kg square. So it's 8 times 0.35 square. To
Okay.
find a relation between AG and alpha, I should find where is my instantaneous center. Okay? Because
okay.
I know, look, in this problem, what is VG? What is velocity of G? Is your instantaneous center at A, yes or not?
Yes.
Yes, as it is rotating about A.
Since VA is 0, okay, so A is my
0.5.
So A is the instantaneous center. It's the IC. When I find the IC, I can say that the velocity of any point, in particular, velocity of G is equal to omega, which is the angular velocity, times the distance between A and G, so times AG. Okay? Now, because G is doing translation, okay, then acceleration and velocity will be along the same line. So I don't have change in direction for velocity and also for acceleration. Therefore, I can derive this vector. Okay, I can derive this relation. This relation is always applicable, and it's only variation in magnitude, not in direction. So to find AG, I simply say that AG here is restricted to AG tangential because it's a rectilinear motion for G is equal to the derivative of VG with respect to time. If you derive VG with respect to time, AG is constant, and d omega by dt will give you what?
Alpha.
So d omega by dt times alpha. Okay, so you can write here that alpha is d omega by dt times r. And what is r here? It's the distance between A and G. So times AG. Okay?
He 0.5.
D 0.5. So I can say that the second relation is AG equals to 0.5 alpha. And now I have two equations with two unknowns. I solve for alpha and AG.
مش سؤال.
نعم.
قلت لنا انه VG is omega times AG وقلت لنا لانه it is translating ما فهمت ليه we can derive يعني
Okay.
دغري نعمل
لأنه
derive.
أنت when you have translation rectilinear translation ال AG tangential بتكون equal لل VG لل AG total صح؟ في AG normal هون شيء؟
لا
لا. يعني to find the acceleration of G you just have to derive velocity with respect to time.
اوكي
بينما لو عندك change in direction الاكسلريشن مش بس بتكون dvg by dt بيكون ال
في
tangential
AN
acceleration dvg by dt بينما بدك تجيب النورمال كومبوننت كمان.
اوكي
اوكي
بس سؤال،
نعم.
لو عزنا الورك كاينتيك انرجي ثيورم مش بتكون اسرع؟ بنرجع we derive with respect to time دغري بيطلع لنا
لا
الاكسلريشن.
البرنسبل اوف كاينتيك انرجي للريجيد بودي حنشوفه بنكست شابتر. اوكي بس هون انت بدك اكسلريشن ما بدك فيلوسيتي يعني مجبور تستعمل this flow
حتى اذا we derive with respect to time لا ساعتها بيطلع لنا الفا مش هيدا. اوكي
يعني
صح؟
هون نحن لقينا general expression for velocity and we derive it to find the general expression for acceleration.
اوكي.
Okay. Any other question on this problem? Okay. So let's do another problem. If you want, if you don't do sum of moment about A, if you do sum of moment about G, then you will have an additional unknown. What is your additional unknown? The tension. So the method we did together reduced the number of equations we need. We just solved for 2 equations. However, if you do sum of moment about G, which is equal to IG alpha, you will involve another unknown, which is tension T. In this case, you need a third equation. What will be the third equation? So if you choose to do sum of moment about G, what will be your third equation?
Sum of moment of forces.
Yes, بصير بدنا نعمل كمان sum of y equals to MAG. So if we choose to do sum of moment about G, what will be the equation? Sum of moment about G equals to IG times alpha, okay? And then what are the moments here? If I choose the clockwise direction as positive, I have 100 times what? Now it's 100 times 0.2. And for the tension T, it's in the opposite direction, so it's minus T times what? The distance from A to G times 0.5. This is my first relation, okay? Now, my second relation is AG equals to alpha R. I need now a third relation because I have 3 unknowns, AG, alpha, and T. The third relation will be sum Fy equals to what? What is sum Fy?
MAG.
Yes, it's equal to
Plus-
MAG because
Metric.
AGY is equal to AG. Okay? And what are forces along Y? I have plus 100 plus tension T minus weight equals to MAG. So I obtained 3 equations with 3 unknowns, AG, T, and alpha. Okay?
Miss,
Now,
how do you know the direction of AG?
yes, how do we know what?
The direction of AG.
Okay, because you have that 100 Newton force is upward, so it will pull your disc up. And how will be your rotation? Okay, you can do this analysis. If I do sum of moment about A, or sum of moment, let's say about G, okay, I have the 100 Newton force is producing a clockwise couple. This clockwise couple will tend to rotate my disk in the clockwise direction, and it will lift my center upward, because when it will rotate clockwise, G will go up.
Pardon?
Yes. Yes. I cannot hear you. Can you please type your question in chatting? كان حدا عم يسأل questions. Can you repeat please? I cannot hear you. So if you need something, please type it. Okay. Any other question? So let us move to another example. The uniform slender pole has a mass of 100 kg and a moment of inertia Ig equals to 75 kg/m². If the coefficient of static and kinetic friction between the end of the pole and the surface are μs equals to 0.3 and μk equals to 0.25 respectively, determine the pole's angular acceleration at the instant the 400 Newton horizontal force is applied. The pole is originally at rest. So here you have a bar, okay? This bar is originally in the vertical position, and you apply on it a force of 400 Newton, okay? What we want to find is the angular acceleration at this instant when we apply the force of 400 Newton, okay? In such a problem, you have a certain method to follow. When they give you both static and kinetic friction, this means that I am not sure if I will have translation, or I will have rotation about a fixed point, or I will have general motion. When I am in this case, I should do an assumption. I should start by doing an assumption. Always I start by assuming translation. So first I assume translation. If I have translation, what is the condition to have translation?
That friction is greater than USN.
No, بالعكس. I cannot have friction greater.
Less than.
If I have translation, first alpha should be what? Alpha is 0, okay? And second,
0.
I should say that in this case, for friction, okay, friction will be kinetic or static in this case?
Kinetic.
Kinetic, because I have motion, okay? So if I have translation, I have alpha is 0, okay? And I have kinetic friction, okay? Can I, let us see if I can have 0 alpha equal to 0. To do this, I should put the my forces. I should do the free body diagram showing all forces acting on my body. For my bar, what are the forces acting on it? I have its weight.
Weight.
I have
and
the
400.
400 Newton force, and I have
Normal.
the normal at A. If I do sum of moment about G, can it be 0?
No.
Well, I have also the friction, okay? What is my friction? If I have translation, my friction should be equal to μkn, okay? So, if we do a small calculation together, we will see that sum of moment about G cannot be 0. Because look, let's do it. Sum of moment about G is equal to Ig times alpha, okay? We want to check if alpha can be 0. So if I do sum of moment about G, I have first the moment of friction, the moment of friction is in the clockwise direction.
Clockwise.
So it's minus F. What is F? Mu K N. It's
Mu K
mu
N.
K. And what is N?
للweight.
mg.
N is equal to the weight here because along Y, sum of Y equals to 0 if I have translation.
98.1.
So N is equal to W. So minus mu K W times the distance from the point at the ground level to G is 1.5 times 1.5. Okay. And I have the moment of the 400 Newton force in the counterclockwise direction. So plus 400 times 1. Okay. If we replace, it's equal to what is mu K? 0.25. So it's minus 0.25 times weight, which is 100. Yeah, until now I have 25 times the distance, which is 1.5. So I get a value that is positive here. Okay, because 400 is much higher than 25 times 1.5. So this value is positive. Because it's positive, so alpha is not, so alpha can't be 0, is not 0. So my assumption is wrong. Okay, so can I have translation here?
No.
No. So my first assumption is wrong. I will eliminate this assumption, and I will go to the second assumption. The second possibility is what? Rotation about fixed point. Rotation about, what will be the fixed point?
A.
Yes, of course, about A. Okay, so if I have rotation about A, what is the condition to have rotation about A as a fixed point? My friction should
VA
be
is
what?
0.
No. Yes, VA is 0, and my friction should be what? Because I don't have motion at A, it should be static. Yes, my friction should be static. So F calculated should be smaller than, so F should be smaller. So F max is what, if you want? F max is, the maximum F can be equal to mu S times N. Okay? This is why I will do my calculation, and I should verify that the friction is smaller than mu Sn. If it's not smaller or equal to mu Sn, then I will say no, my assumption is also wrong, and I have general motion. So I have rotation plus translation. So to verify if I have rotation about a fixed point, I will put my unknown. I have the friction F that is unknown, but I should verify that it should be smaller than mu Sn. I have the acceleration of G that is unknown, but how will be a G? G is doing what? G is doing rotation about A. So I have a G tangential and a G what? Normal. But because it's starting from rest, what will be the normal acceleration?
0.
So this is AG. This is AG tangential. This is AG normal. And here AG normal at this instant is 0 because I'm starting from rest, so V is 0. And I have the friction force F. Okay? I still have an unknown. What is the unknown? Alpha.
Alpha.
Yes, alpha. And I have my normal reaction, which is also unknown, and I can calculate it. I have N. This is N. Okay? So to find my unknowns, I have N, F, AG tangential alpha. I have 4 unknowns. I need 4 equations. Let's start by the first equation. What will be my first equation? Some FT.
Moment about G.
Yes, as you like. So we can start by moment about G. Sum of moment. Here you can do or sum of moment about G, or sum of moment about A. Why you can do here sum of moment about A equals IA alpha?
Homogeneous rod.
No, because A is fixed. Okay, لو كان A instantaneous center, you cannot say sum of moment about A equals IA alpha. But because it's rotation about fixed point, then you can put that sum of moment about A is equal to IA times alpha. And do you know what is the inertia about the extremity of a rod?
مش ml squared over 12 شي هيك.
Over 12 هي about the center G. Is about the extremity, I can apply what? Parallel axis.
Parallel axis theory.
Okay, so it will be plus ml over 2 square, which will give me ml square over 3 as the final result. So it's ml square over 3. You don't have to remember this because you can have the formula sheet with you in the exam. Times alpha. This is my first equation. What are the forces doing moment about A?
AG.
Friction.
No, AG, please انتبهوا, AG is not a force. Okay? Friction لا, لأنه friction passes through A normal passes through A والweight كمان passes through A, يعني only 400 horizontal force is doing a moment about A. And I will choose the clockwise direction as positive. So I have 400 times distance is 0.5 equals to ml square over 3 alpha. The only unknown in this equation is alpha. I get alpha. Okay? So I am done with my first unknown alpha. What is the second equation I can use? When you have your rotation about fixed point, how you can relate AG tangential and alpha?
Summation of x. Summation of x.
Yes, but قبل summation of x. When you have rotation about a fixed point, what is AG tangential?
Alpha times
yes, very good.
R.
Alpha times R. And R here is what? The distance between A
1.5.
and B. 1.5. Okay? Times 1.5. Okay? This is my second equation. I already calculated alpha, and this relation will give me AG tangential. I still have only two unknowns, which are N and F. To find N and F, what should I do? Sum of N and sum of T. Okay? So I will put again my forces. I have the weight downward. I have an A upward. And I have the 400 Newton force and the friction force. Okay? So now I can write that sum of T equals to MAG tangential. Along UT I only have what? No, I have two forces. 400 minus what? Minus F. Okay? I already calculated AG tangential, so I deduced that the value of F. So F is equal to 400 minus MAG tangential. Okay? And if I do sum of normal forces, here it's equal to, in general, to MAG normal. But here, because it's starting from rest, so it's MVG square over radius, which is 1.5. But because it's starting from rest here, it's equal to 0. So I can deduce that it's N. If I'm doing along UN is downward or upward?
Downward.
Downward, because always it's directed towards the center of rotation. يعني it's plus W minus N equals to 0. هلا هون ما بتفرق لأنه 0. Okay? So I deduce that N is equal to W. Okay? Once I calculate N and once I calculate the friction F, I should verify my assumption. So I should compare. So now I can compare F and mu s n. If F is smaller than mu s n, it means what? My assumption is true or wrong?
True.
true. And if I obtain f higher than mu Sn, my assumption is wrong and I should repeat everything. If I repeat everything, I will be sure now that what is the type of my motion. So if my assumption is wrong, then I can say I have general plane motion. And in case I have general plane motion, okay, what will be my unknown in this case? First, if it's general plane motion, it means that it will slide. If it will slide, what will be my friction, static or kinetic?
Kinetic.
Kinetic. And once it's kinetic, it's not unknown anymore. It's equal to what? So I am sure that F is equal to mu K times N. So F is not unknown anymore because it will be function of N. Okay? So I reduce the number of unknowns because instead of having F and N, I only have N unknown. Now, what are my other unknowns? For my center, for G, okay? Now G is not doing pure rotation about A, so I cannot write any more AG normal, AG tangential. I will write, I don't know how is AG. This is why I will decompose it into two components, AGX and AGY to be calculated, okay? So I have two unknowns here for AG, which are AG